Hi, this is Vasavi from At Home Tuition. This video is about the SSS Similarity Theorem. By SSS, we mean the side. You may get confused with that of the SSS congruency theorem. Actually, in SSS congruency theorem, you have all the sides equal. The three sides of the corresponding sides of the two triangles would be equal in length, or they would be congruent. But here in the similarity theorem, the three corresponding sides of two triangles are always proportional and they are not equal. Just note this point. They are just proportional and not equal. Now coming to the SSS theorem, it says if in two triangles, sides of one triangle are proportional to the sides of the other triangle, that is, if they are in the same ratio, then their corresponding angles are equal and hence the two triangles are similar. So this is what the theorem says and we are going to prove this. Okay. So first let us note down what is given and what is to be proved. Given that the sides are proportional, right? So you have two triangles here like ABC and DEF. Okay, the two triangles are ABC and the bigger triangle DEF. So they say the sides are proportional. So how can the sides be proportional? AB by DE, which is equal to BC over EF, and finally you have AC over DF. So this is what is given. We need to prove angle A is equal to angle D, angle B and angle E are equal, and angle C is equal to angle F, right? Okay, let us see how to prove this. So, before getting into the problem, I have drawn the point PQ here, okay? The P and Q, where P cuts the DE such that your AB is equal to your DP, okay? So you need to draw the construction. So the construction is draw PQ such that, okay, such that your AB is equal to DP and your AC is equal to DQ. So such a way I have just drawn a line PQ. From the given proportion, I just take this AB and AC, okay, the two sides. So, and I say instead of writing AB over, see, what is given is AB over DE is equal to AC over DF, right? Just take those two alone. And I am going to replace the AB and AC with DP and DQ, right? Because they are equal, right? So I can replace it with DP over DE is equal to DQ over DF, right? Okay. Now I'm going to flip this. DE over DP is equal to DF over DQ, right? And in the next step, I'm going to subtract 1 from both. So I would write DE over DP, take away 1 is equal to, when I take away 1 from my left side, I have to do that to my right too, right? So that the value doesn't change. So here it is DQ minus 1 here. Now this could be written like DE over DP, and this 1 I write it as DP over DP, okay? Because the denominator is DP, I need to have the same denominator for both. So I just did this, and similarly here also you can do this, okay? This is going to be DQ minus dq over dq. So this implies, just see, look at the picture, dE minus dP, right? dE is this whole portion. If you take away dP, you're left with PE, right? It is PE. So I can write PE over dQ is equal to, the other side it is QF. So it is QF over this dP. This one, right? This one will be PE over dP, and here this is this side on my right, it is dF minus dQ is QF by dQ. Okay, so we got this much. So now just see, this says that in this triangle, in the bigger triangle, I'll just draw that roughly here. In the bigger triangle where you have your D, E and F, okay, and this P and Q over here, you join them, and you know that PE over dP is equal to, oh, this is F, this is F. So here it is QF over dQ, right? So what does that mean? It means that the lines are parallel. When the sides are proportional, I can say that PQ is parallel to EF, okay? The side EF, I'll tell you why. Because of the BPT theorem. Remember? By BPT, the basic proportionality theorem. In the basic proportionality theorem, you learnt that if the sides of two triangles are proportional, then the third side would be parallel, right? So we got the PQ parallel to EF now. So since these two lines are parallel, now we can say that angle P is equal to angle E, right? Because they both are corresponding sides, and angle Q, okay, I just put two lines here, will be equal to angle F because they both are corresponding sides. So that implies angle P is equal to angle E and angle Q is equal to angle F because they are corresponding angles, right? Corresponding angles, yeah. So we have the reason. Okay, now since these two angles are equal, now two angles of the smaller triangle is equal to the two angles of the bigger triangle, right? So I can say that these two triangles are similar. So from this I conclude that therefore triangle DPQ, okay, DPQ is similar to triangle. See, you have to be little careful while you are writing this. For D it is D only, that is a common angle, and for P, E is equal, right? So in the place of P you put E, and for Q it is F. So these two triangles are similar, and here this is because by angle postulate, okay? Since the two angles of the smaller triangle is equal to the two angles of the bigger triangle, I say that DPQ is similar to DEF. So now we are using all the theorems we have learned before. Since these two triangles are similar, I can say that the sides are proportional. So I can say DP over DE is equal to DQ over DF, which is again equal to PQ over PF. Okay. So we concluded this is because corresponding sides of, these are corresponding sides of similar triangles, right? Since they are corresponding angles of similar triangles, I can say that the sides are equal. Now I replace the DP and AC with the original value because we know DP is equal to your AB, right? So I just replace it with AB over DE is equal to, and DQ was AC, right? So AC over DF, and here this one I write as it is, okay? So this is PQ over, because we don't know whether PQ is equal to BC. So I can't replace this PQ, so I just wrote it as this. This is because your DP is equal to AB and DQ is equal to AC, right? So I have replaced. I can also equate this AB over D. This I take it as equation 1, okay? AB over DE, AC over DF, BC over EF is what is given, right? This is already given, is it not? So from 1 and 2, what we know is, see, if AB by DE and AC by DF is equal to PQ over EF and BC over EF, I can say from 1 and 2, we can very well say PQ over EF is equal to BC over EF, right? That implies your PQ is equal to BC. Understood? So hence, since your PQ is equal to BC, now you understand that triangle ABC, instead of DPQ, I write ABC because they are also the corresponding sides, right? So equal sides they are. So I can write triangle ABC is equal to triangle DEF now, and hence you have shown that this, I would say, because of by SSS, your angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Okay, did you understand? So you have proved the theorem. It may look complicated, but if you just go through this step by step in detail, it is very easy a theorem to be proved. Okay, bye, see you in the next video.